useState is one of the most fundamental hooks in React, and it's usually the hook that React developers learn first, right? First, you start with useState, then you move on to useEffect, and then you decide to never use React again. At least, that's what my comment section keeps telling me. No, but in all seriousness, useState is a great hook, and it's so fundamental to React that I don't think that you can actually have a React application without having some sort of state in it. Now, although useState is a much simpler hook than useEffect, and it's much more difficult to actually do something wrong with it like it is with useEffect, there still are some ways that you can actually mess up using useState in ways that you can introduce performance problems in your components in your application, and also bugs that can be very hard to debug. So in this video, I want to take a deep dive on useState and show you all the potential ways that you might be using it wrong, and of course how to fix it, and all of this in the name of making you a better React developer. Oh, and by the way, speaking of becoming a better React developer, if you haven't checked out Import React, which is my newsletter that's all about React, which by the way is completely free, you definitely should, because on top of getting fantastic content about React in your inbox every single week, I'm also going to be launching something completely new. I've been building in stealth for these past couple of weeks and months something that doesn't really fit into the existing categories of a course, a bootcamp, or a tutorial. It's something completely new, completely different, and I genuinely believe that this is going to be the future of how you are going to be learning React. Now, I can't really say much more than this for now, but what I can say is that the newsletter is going to be the best place to be the first one to hear about it. So I highly recommend. It's going to be linked in the description down below. Now, let's get into the video. Alright, so let's begin and let's talk about useState. Now, the way that we're going to do this video is I'm first going to show you this component over here, which pretty much violates all of the ways that you don't want to use useState. We're going to look at it, understand what is wrong here, and then I have a couple of examples here that are going to show you the correct way of doing things, and each example is going to focus on one part of this component, because as you're going to see, this component is doing too much. So what we have here is what I like to call a wall of state, right? This is when you have a bunch of state variables in the same component that all hold different values that are not necessarily related to one another. And then we have a bunch of useEffects over here that are listening to those values and then making some changes, performing some updates as a result of those values. Oftentimes, we're going to be updating some state as a result of another state changing. And then if you scroll down, we actually have the JSX that is rendering the UI of this component. Now, don't focus on this part. This is here only to exist, right? We're not even going to look at it in this video. I want you to focus on these useEffects over here and then these state variables here. All right, so what's wrong with this code? Well, there's a couple of things. The first one that I think is important and doesn't really get mentioned enough is the fact that when you have a lot of these state variables here and all of these useEffects, it makes the component very bloated and very difficult to understand and to maintain. Right? For a developer to be productive here, they have to spend a lot of time understanding each one of these variables here, each one of these useEffects, and understand what they're actually doing and why they're there in the first place. And this is really important, especially when you're working within a team, because it slows the entire team down. So generally, you want to avoid writing a lot of complex code like this in bloated components and instead opt for simpler components that only do one thing because they're much easier to maintain and much easier to work on. But that's just something small. There's actually a very big performance problem with writing code like this. And that has to do with the fact of how useState works under the hood, the basics of useState. So useState, right, is a hook that we use to create stateful variables, variables that can change over time. And the way that those variables change over time in the context of React is whenever you call this updater function here by a useEffect or a button wherever in your code, it is going to tell React that we need a new value for this state variable here. So React is going to re-render the component to show that new value. You cannot have the new value shown until the component re-renders. This is how React works. And so when you have a bunch of these state variables here, every single time that any of them change, the entire component re-renders, which means that all of the other code that is not necessarily related to this variable is also going to re-render. And this is bad for performance because the more state variables you have, the more re-renders you're going to have. And a lot of those re-renders are going to end up recomputing a lot of values. They're going to end up re-triggering a lot of these useEffects, and you can actually shoot yourself in the foot performance-wise if you have a bunch of these re-renders, and you can also introduce bugs if you're not careful. This is especially especially a problem if you're rendering here expensive components that are constantly re-rendering and rerunning expensive computations. And all of this, as bad as it is, actually gets multiplied in this specific example with all of these use effects over here. Usually, useState tends to come with use effect, especially if you don't really know what you're doing. You would create a useState, you would create a use effect for it, which just amplifies the entire solution. A problem, actually, not a solution. This is in no way a solution. Like here, we have this use effect, right, which is listening to the first name and the last name, and then every single time that any of them change, we're then calling setDisplayName, which is yet again going to trigger another re-render of the component. So every single time that the first name or the last name change, we're going to re-render the component once. Then this use effect is going to run. It's going to re-render the component once again. Imagine all of that for all of these state variables here. You make one update, you get like 10 re-renders. This is inefficient. See, we're doing it here with this use effect. First name, last name, we're updating the form is valid. Then when form is valid is changing, we have another use effect here that is then going to update the set validation errors. This is like a cascade of use effects, right? Which again is inefficient. One update leads to many re-renders. Then here we have this use effect that is updating the set internal counter, which as you can see here is not even being used anywhere in the component, right? So this is a value that actually doesn't even need to use state. And we're going to look at that in example number 5. That's also something that a lot of developers do. They tend to put state for things that shouldn't really be state. And then we have the similar thing here with this use effect that is looking at the filtered items. Same concept, just on a different variable. So now that we understand what's wrong with this, let's actually fix it. Now we're going to fix it in multiple parts. The first thing that we want to do when fixing things is to first realize that we have different categories here. We have different pieces of state that relate to different things. For example, we have these 5 state variables over here that are all related to a user form. We can call this a user form, right? The first name, the last name, display name, is the form valid, and do we have errors? Then we have these state variables over here, these 3 variables that are related to the items and the filters. And then we have this one loose one, this internal counter, which is its own category. So the first and the easiest thing that you want to do is simply create separate components for all of these categories and then isolate them together. That is already going to fix a lot of these re-render problems, because now if you put this in a separate component, if anything in there re-renders, it's only going to re-render that component and not everything else. And this is what that would look like. So now we're in page 2 over here, and the only thing that we did here is we just split this into 3 separate components. We have the user form, the item list, and then the counter. Everything else is the same. So this user form here only has the state variables related to the form, so the 5 variables here, and it also has the use effects related to it. Again, this is not the final version of it. This is just the first step and the easiest step that we can do. Then the item list, if you scroll down here, has the state variables related to the item list and then the use effect that goes along with it. And finally, we have our counter component, which has the same internal counter and the same use effect to update it. This is already better because, as I said, now everything is isolated. So if the first name changes, we're not going to re-render the item list, we're not going to re-render the counter, and everything is much more efficient. Developers can now work on any of these components in isolation without worrying about the other components or affecting anything in the other components. It's also easier to understand and easier to maintain, right? So again, this is the first step, and this is the easiest step that you can do. Now, the second step, the bigger step, and the one that you should actually do is you should realize that we don't actually need to have state for all of these variables here. Some of these variables we can actually derive instead of having state. For example, this display name. We don't need to have a separate state variable for the display name, which is then going to require a separate use effect to then listen to the first name and the last name and update that display name. What we can do instead is we can actually derive the display name instead. So what that means is we can come here and we can do const display name equals to first name, last name, and then trim. This is essentially the same thing that we're doing here. But instead, now we're going to come here, remove it from state, and now we're going to remove this use effect over here because we don't actually need state for this. The display name can just run as a variable computation during render. You can do this in React, and this is encouraged. This is going to listen to the first name and the last name and is going to compute on demand every single render the display name. And this is better because now the display name is always going to be in sync with the first name and the last name. Because remember, if the first name or the last name changes, React has to re-render the component for us to see the new value, which means that we're going to get a new render and we're going to get a new computation of display name. So it's always going to be kept up to date without the need for state and without the need for use effect. So this is better. We can also apply the same logic with the isValid over here. We can do the exact same check over here and not have another state variable for it. So I can come here and I can just do const isFormValid, and we're going to put the same condition here. Then we come, we remove the state, we remove the useEffect, because again, we don't need to recompute something that can be derived. You always want to think if you can derive state instead of computing it. Always choose to derive. So already we got rid of two state variables. Our component is now much simpler and there's much less reasons for it to be rendered. So it's much more performant. Now, when it comes to these validation errors over here, we can't quite do the same thing because this should be state. This should be something that can change over time. We can actually have different validation errors based on different properties. They can't really be derived. So what I would do instead is I would take this and I would actually put this instead of a useEffect, I would put this directly inside of this handle submit function. So this is what that would look like. We're going to check instead of on a useEffect. So whenever isFormValid changes, we're actually on submit. So whenever the user tries to submit the form, we're going to check is the form valid. At this point, our valid here is going to be updated based on the first name and the last name. So we'll have the up-to-date value here whenever the user tries to submit. And then if the form is valid, we're going to be inside of this block over here. We're going to set the validation errors to an empty array. And then we're going to take this over here and we're going to put it here. This is a substitute for our submit function. If the form is not valid, then we're just going to set the errors, please fill in all the details. And that is going to automatically update the UI. And then we can come here and get rid of this useEffect because we don't need it. This is now handled directly inside of the handle submit. So see what we did here? We removed two state variables and we removed every single one of our useEffects. This is great. Our component is now super efficient. We can of course apply the same exact logic with our item list over here. We have items, this needs to be state because this can change over time. This might change from props, right? If we have it from props, this needs to be state. This filter here also needs to be state because we need to be able to change the filters to show something else in the UI. But these filtered items over here don't need to be state. These can actually be computed on demand. And they can be computed just like this by creating this filtered items here. Let me remove the state variable here. Let's import useMemo because in this case, you might want to use useMemo if you're not using the React compiler. And then we can come here and we can clear this useEffect because again, we don't need an extra useEffect just to sync a variable. Now, in this case, yes, we do want to use useMemo or let the React compiler do it just because we have a list of items here, an array that we're going to call .filter on. So we're going to do an operation for each element and we generally want to avoid doing that unnecessarily. So we wrap it in useMemo. If you're using React 19, or actually if you're using the React compiler because you can use it in React 17 and 18, you don't need to do this. The React compiler is going to do it automatically for you. And now with this, our item list component is also much simpler, right? It only has the state variables that it needs and it no longer has any useEffects. This is great. Finally, we can come here to our counter component. And in this case, there's nothing that we can do in terms of removing state and removing things that derive it, because we still might want to have this useEffect that runs every single second to increment the counter, right? So we need to keep that. So for now, we're going to leave this be. But again, on page 5 here, the 5th example, we're going to make a change to this that you don't want to miss. Now, let me show you a different way of solving this problem because I really think that this is important. Let's come here to page 3. This is the same example of our user form. So in this case, we're only going to be concerned with the user form just to keep things simple. Instead of using a bunch of states here, we can actually use an underrated hook and an underused hook from React, which is useReducer. So useReducer essentially acts as a superpower state. It allows you to have more complex state that you can update in a very predictable way. So here, instead of having all of our state variables, which would be first name, last name, and validation errors, we actually have them all inside of this reducer by this form reducer here. So let's see our form reducer and how it works. So I'm going to scroll up here and we're going to take a look at it. So the form reducer is a function that takes in the state, which is going to be this form state over here, which as you can see has all of our values. The first name, the last name is our form valid, and then the validation error specifically to that form. And then it's going to take an action, which is going to be either one of these. It's going to be of type set field, and the field is going to be first name or last name. So which field do we want to perform the action in? And then the specific payload of that field. In our case, it's going to be a string. It's going to be the actual value that we wanted to set in that field. And then what we're doing here is whenever we have the set field action, we're going to take the state. So we're going to spread the existing state, whatever we had previously, and we're just going to set the new value in the state as the action.payload. So essentially, if this is first name, we're just going to set first name here to the new value of the first name, because because again, this represents our entire state in one single object. That's what useReducer does. And then here we can actually calculate is our form valid using the same exact checks as we have before, right? New state.firstname.length and then the last name as well. And then we can actually get our validation errors in the same exact way and just return all of them as part of our state, all in one operation, which is really cool because now our component just has this state here and then dispatch. And the only thing that we need to do inside of here, whenever we're updating any single value, we're just dispatching a specific type set field, which field we're on, and then the payload. And then everything else happens automatically. We don't need to have any use effect that listens to anything that runs some code. We're doing all of the code in a very predictable way inside of our reducer here. And all that we have to do is send the action with the type, the field, and the payload. This is efficient. And this is, again, another way to solve this problem here. Instead of having multiple state variables, you can have one with a reducer and just manage it that way. But again, you can also do it this way by just being efficient with your state variables and having just a few state variables instead. Both approaches are totally fine, and there's different use cases for each approach, and you can use which one fits the best for what you're trying to do. Now, if we come back here to our item list, there's actually something else that we can do, and this is actually another way that you might be using useState wrong, which is not everything needs to be local state. What I mean by local state is state that lives in React components, state that lives in the memory of your browser. Because if you look at these filters here, because we are using useState, whenever the user refreshes the page, that state is going to be lost, right? That memory is going to be lost, and we're going to be defaulted back to this default value, which is an empty string, which is not always the best user experience that you want your users to have, right? Imagine you have a very complex filters with a bunch of different properties. Maybe you are using useReducer for your filters, and then the user sets all of these filters up. They're super happy with what they're seeing on the screen, and then they refresh the page and it's all gone. All that work is gone. You don't really want to have your users go through this. And so for things like that, I would not recommend that you use useState. I would instead recommend that you come here and you look at page number 4, example number 4. You use something that we call useQueryState, which essentially means you use the URL bar as your state. So here we're using useQueryState from Nux. This is just a library that makes it super easy to actually work with state in the URL. And this basically just returns a very similar, actually the same signature as you get with useState, but now the state variable is going to be persisted in the URL. So it's always going to be in the URL, and the URL is basically your state manager at this point. And this is really cool because from a user perspective, your users now can refresh the page as much as they want. They're going to see the same exact state just as they left it, and they can also share that URL to somebody else, and that person can open that URL and see exactly the same thing as your first user will. This is really cool. And for you, in terms of the developer, nothing really changed besides using a different hook and maybe specifying some optional properties. Because again, this works exactly like your useState. It's automatically handled by Nux, which is cool. That's why you would want to use a library like this for the URL. The only thing that you have to do is provide the name here, which is the actual key that is going to show up in the URL, and then optionally some default values or some configuration as to how you want this URL to behave. You don't always have to provide these optional values. The only thing that you need to provide is the actual name in the URL. So it makes it super simple. And then everything else remains exactly the same, right? Which is really, really cool. And also in this example, I realized I actually split things up into separate components, which is also a bonus, right? This component now looks super simple. This item here, this page 4, which is like the item list, looks super simple because it's only rendering a div with 2 different components here, and we're just passing the props that we need, right? So now we have separate components that we can reuse across the application if we want. We just have to export them or maybe put them in a separate file. It's up to us how we want to do it. And they're also super easy to understand, to maintain, right? They're just literally small components doing one thing. And this is generally a better approach to build your state and your React components and your React application. And finally, there's one more example that I want to show you, and that is, again, that sometimes you don't actually need to use state. So this example over here is only concerned with our counter, right? So it's only concerned with this internal counter state variable over here and nothing else, because we've already covered everything else. So what we have here is, instead of state, we're using ref. And then we're doing the exact same thing in this use effect. We're incrementing it on a 1 second basis. We have a 1 second interval, and we're just setting its value to its value plus 1. just like we did with the state version. And the reason why we did this, the reason why we're using ref instead of state, is because you shouldn't use state for things that are not going to be rendered in the actual JSX, in the actual user interface of your components. If something is not needed there, then you actually don't need to have state for it. Because remember, state variables in React, they're built so that when you update them, the component re-renders so that you can ultimately show them on the screen. All of these variables here, we needed them to actually show them on the screen, to show something in the UI. But in our case of this counter, this is an internal counter. It's not shown anywhere in the user interface, and it's not used by some other properties to show anything in the user interface. This is just an internal value that does not belong in the UI at all. And for those values, you don't want to use useState and you want to use ref instead. That's what ref is built for. Because if you use useState, then every single time that you're changing those values, right, you're going to re-render the component. But if there's nothing in the user interface that needs to change as a result of that value, that is then an unnecessary re-render. You don't have that with ref. useRef is a place that you can put values. You can actually put anything in here. That's a place that is kind of separate from the React lifecycle, and you can just store things that you might need in your component, but you don't need to show in the UI. For example, this internal count, right? This is actually going to hold the value of the count, and every second it is going to update that value of the count, and you can actually do things with that value. But you shouldn't do something that you need to show it in the UI. If you need to show this count in the UI, maybe allow the user to even update the count, then you would use useState. But if you don't, you use ref. And this is something that a lot of junior developers don't understand that you can do or that you should do. Not everything that goes in your component needs to always be state. And I hope that by now you understand the trade-offs, the drawbacks of using state. State is not free. It comes with benefits, but it also comes with costs. And you, as a React developer, need to understand when you should use state and when you should avoid using state, as opposed to something else, like a ref. So there you go. We covered all of our examples. We have 4 good examples and 1 bad example. I hope that in this video, you were able to understand why doing it this way is wrong and all the potential problems that comes along with it. And I hope that you can now understand how to actually solve it, and more importantly, how to think about solving it, right? Going back to what I said in the beginning of this video, React needs you to adopt and learn a mental model for you to be able to use it effectively. This is that mental model. Understanding when to use state, when to not use state, when to use effects, when to not use effects, and when to use refs, and all the other tools that React has. I'm not sure what happened here. I think I broke my user interface. There you go, it's fixed. Is a fundamental skill of what it takes to become a good React developer. So think about these lessons here. Think about what you've learned. Play around with this, try to fundamentally understand this, and look into your own applications to see if you've made any of these mistakes here. And if you did, try to fix them, and I promise you, you will become a better React developer. So that's it. That's all that I have for you today. If you've enjoyed this video, of course, leave it a like, subscribe. It really does help out the channel. My name has been Kazan. This is Kazan Solutions. Thank you so much for watching, and I will see you in the next one. Ciao, ciao.